Hello, my dear children, especially class 12 students of CBSE board who have to appear for the chemistry exam on 28th February. I'm very sure you have prepared well and are on your last stage of revision. Wish you all the best. I'll be quickly revising the most probable areas of the chapter D and F block elements with you. So let's start with the general properties of D block elements. So I'll try to make it as simple as possible. So I'll club three properties which start with the alphabet C. And these are: number one, most of the D block elements form colored compounds. Then the other properties, most of them form very good complex compounds. And the third one is that many of them act as good catalysts. Coming to the reasons for these properties. Number one, why do they form, most of them, why do they form colored compounds? So the answer is that in these there is a possibility of DD transition. So a DD transition will be possible only if there are unpaired electrons. So if there is a comparative question, like suppose the question is why zinc salts, where Zn is present in +2 state, why zinc salts are colorless, whereas say copper salts, where copper is present in +2 state, are colored. So you can answer it this way, that in zinc ion present in the zinc salt, there is no unpaired electron, so DD transition is not possible, whereas in the copper salts, in copper there are unpaired electrons, and hence we find that DD transition is possible. Then coming to the next property, that why do they form very good complex compounds? So the reason is they have got small ionic sizes and high charge density. And another point is there that they have vacant d orbitals. So just go through these reasons again and again. Just go through these reasons so you'll be able to recall them during the examination. And the third property was that many of them act as good catalyst, and the reason is, number one, they have got very good surface area to act as good catalyst. Number two, they are capable of forming different intermediate compounds with variable oxidation state. And another thing, that they have got vacant d orbitals. So that takes care of these three properties which start with the alphabet C: colored compounds, complex compounds, and catalysts. Then coming to the other very important properties, so let me take up the property of the atomic size or atomic radius. And that is that as you are moving from left to right, the size decreases. After midway, you find sizes start becoming similar, and this similar size parameter is the one which is used for making alloys. So if a question is why is it that many of the D block elements are used for making alloys, so you can say that because many of them have got similar size. Then going back to the property related to the size of the atom, as you move down the series, you find within a group there are elements which have similar sizes. For example, zirconium and hafnium, they have similar sizes, and the reason is lanthanide contraction. Then another very often asked property is that as we move from left to right, we find that the melting point, boiling point, and enthalpy of atomization increases till midway in the series. Means as you are moving from left to right till you reach the middle element, you find that melting point or boiling point or say enthalpy of atomization keeps on increasing, and then after midway it starts decreasing. Of course, there is an exception in between. You find that manganese and technetium, they show a little exception, but otherwise the general trend is left to right it increases till midway, and then after midway it decreases. And the reason is, as you move from left to right till midway, number of unpaired electrons increases, and then after midway pairing starts, so number of unpaired electrons starts decreasing. Then coming to questions related to the stability of the oxidation state. So I'll first of all take a question which is asked many times. It has been asked many times. So it's a probable question, and that is that Cr2 plus, chromium in plus 2 state, is a very good reducing agent. What does it mean? That it can easily get oxidized to Cr3 plus. And the reason is that in Cr3 plus state, we have exactly half filled T2G3 configuration, which is very stable in aqueous solution. Then other questions which can be asked from oxidation state is that why the reduction potential of Cu2 plus is positive. So we must remember that less the stability of an oxidation state, higher would be the value of its reduction potential, or positive would be the value of the reduction potential. So that indicates that Cu2 plus is not stable in aqueous solution, hence has a tendency to go back to Cu. And then the reason could be written as this, that the sum of sublimation enthalpy and ionization enthalpy is much more than its hydration enthalpy. Then a similar question which can cause a little confusion is that Cu plus disproportionates to form Cu2 plus and Cu in solution. Now this indicates that Cu2 plus is more stable than Cu plus. And here again the reason is hydration enthalpy of Cu2 plus compared to Cu plus is more negative, correct? Then coming to certain other questions based on oxidation state and reduction potential, which have been asked many times, are that why the reduction potential of manganese 2 plus, or say zinc 2 plus, or nickel 2 plus is highly negative. And the reason is that these elements in plus 2 state in aqueous solution are very stable, hence their reduction potential is negative. Manganese 2 plus is stable because it has got exactly half filled D5, and Zn2 plus has got exactly fully filled D10. Nickel 2 plus, in that case we find that the hydration enthalpy is highly negative, so it is stable in the plus 2 state. Then coming to properties related to magnetic nature, I think we all know, all of you are very intelligent, you must be knowing this, that a species will be paramagnetic if it has got unpaired electrons, and a species will be diamagnetic if all the electrons are paired. And questions related to magnetic moment should be calculated. The calculation should be done of the magnetic moment by using the spin only formula. I think you all know. I'll repeat for you. That is, the magnetic moment is equal to root of n into n plus 2, where n is number of unpaired electrons. And you can also remember that iron, cobalt and nickel are ferromagnetic substances. Then coming to interstitial compounds, they have a capability of forming interstitial compounds which are very hard and inert. Then we come to lanthanides and actinoids. But before going in for lanthanides and actinoids, I would like to mention here that there would definitely be a question based on potassium permanganate or potassium dichromate. So my suggestion to all of you is that please remember the preparation of potassium dichromate, preparation of potassium permanganate, and their oxidizing reactions where they are acting as an oxidizing agent. Then coming to F block, and that is lanthanoids and actinoids. So in lanthanoids and actinoids both, the most stable and common oxidation state is +3. Then second thing which I want all of you to revise thoroughly is lanthanoid contraction. Definitely one question I feel will be asked from this part, And there could be, three types of questions based on lanthanoid contraction. Number one, what is lanthanoid contraction? And the answer is the regular decrease. So underline that, regular decrease of atomic size or ionic radius as we move from left to right in the lanthanide series. Another question could be, what is the reason for lanthanide contraction? And the answer is ineffective shielding by 4f electrons. Just simply write it this way. Then another question could be, what are the consequences of lanthanide contraction? So you can write the consequence mentioned in your NCERT, that is zirconium and hafnium are having similar sizes. Then one more thing which I feel every child should revise, and that is at least 4 differences between lanthanoids and actinoids. And many a times I find this question coming up in the board papers, and that is, what is mish metal? That is given under applications of lanthanoids, and mish metal is an alloy of lanthanoids. It's a magnesium based alloy which is normally used for making bullets or shells, etc. So just go through that part also. And another point which I think you all know, that actinoid contraction is more than lanthanoid contraction, although lanthanoid contraction is more important than actinoid contraction. All the actinoids are radioactive, and in lanthanoids only one element, promethium, is radioactive. So I tried to cover all the important areas of this chapter, or rather which I felt that most probable areas from where the questions can be put up. So I'll repeat again, go through these properties, and definitely you must revise preparation of potassium dichromate and preparation of potassium permanganate and their reactions which tell us about their oxidizing nature. So wish you all the best, do well in your exam, and I'm very sure all will be preparing well, and please do go with a very calm mind during the exam. So God bless you.